Well, good morning everyone, and welcome to the University of New South Wales and to the Australian Centre for Advanced Photovoltaics second annual conference. Well, what my job is to just sort of give a brief overview of ACAP for those that of you that the whole concept might be new to, and also talk about some of the developments that have been happening in photovoltaics that may be relevant to ACAP and its activities. So that's what I'll kick into now. So recent developments in photovoltaics and ACAP's mode. I'll explain a little bit about the organisational structure of ACAP during this presentation, but I'm actually director of the Australian Centre. So this is the big picture, what's been happening in terms of new electricity generation capacity added worldwide over the last few years, and photovoltaics, which ACAP's exclusively concerned with, is up the front there. So the most rapidly growing of the major electricity options, and last year for the first time it actually got slightly ahead of wind in terms of the amount installed. So of the new renewables, it's likely to take over as wind. I think from now on it's likely to be ahead of wind in terms of capacity added. Coal is still king, but still king in terms of new capacity additions, but that's expected to change over the next 5 or 10 years, as this chart from Bloomberg suggests. So the same type of information, plotted slightly differently, but the photovoltaics is the yellow bit up the top there. This is the photovoltaic component, and coal is expected to decrease over the coming decade. So there'll be a transition sometime over the next 10 years, according to Bloomberg, where photovoltaics will take over as the electricity option installed in the largest capacity. So I guess we're doing important work. We're going to have some type of impact upon the energy system. How far might it go? This is a slide I love showing, done by the German Advisory Council on Global Change, mainly because it was done before the turn of the century, the work backing it, but a lot of their expectations have come to be fulfilled. But this just shows primary energy demand over the coming century, expected to quadruple, but increasingly taken up by the more sustainable options, wind, biomass, and solar, with solar becoming one of the major contributors to primary energy by mid-century, and the major contributor by the end. You can get a better idea of how we're going against that plan by this chart here that shows the same information but a logarithmic scale here, because photovoltaics, when the plan was done, was minuscule in terms of the amount of capacity that was there, but expected to grow very quickly as shown by this red line. So that was the plan's expectations. Similarly for wind, starting from a larger base but growing quickly. Nuclear starting from quite a well-established position. So you can see that wind has lived up to expectations, but photovoltaics as capacity has increased, extremely rapidly. And last year there's 140 gigawatts of photovoltaics total installed worldwide, cumulative, and that was the target for 2020. So exactly 7 years ahead of where that plan expected us to be. So if we can keep that up, we might get to this 25% of world's energy 7 years earlier. So sometime around 2040. So that's looking more realistic a possibility than when the German study was first done, when there wasn't really any experience with photovoltaics at a large scale. So good news on that front. What's been driving the growth has been the cost reductions, and they occurred mainly a year or two ago. This is just reported manufacturing costs for different major manufacturers. And you can see that some manufacturers are now reporting less than 50 cents a watt US manufacturing costs. So there's been a slight decrease over the last year, but those incremental improvements are expected to continue sort of indefinitely into the future. So a recent survey of industry experts suggested that present manufacturing costs would halve again over the coming decade. So that's the expectation, ongoing incremental improvement leading to cumulatively large decreases in the cost. So with the cost of traditional energy going up, it's likely there'll be a transition sometimes over that decade from solar being one of the higher cost options to becoming, in fact, the lowest cost option for electricity production. Talking a little bit about ACAP now and its and its organisation, we're actually funded under a scheme intended to boost US-Australian collaboration, so that we have a strong US participation in this conference as a consequence. But we actually have, the overarching organisation is the Australia-US Institute for Advanced Photovoltaics. We couldn't decide how to spell centre, so we picked on the word institute for that overarching organisation. And we have an international advisory committee that guides the activity, and their main role is to coordinate activities between the Australian Centre for Advanced Photovoltaics, which is represented by many of the people here, participants in that, and by the collaborating US organisations, primarily NREL and Arizona State University through their centre, QESST. So as well as this international advisory committee, we have our own management structure for the Australian Centre. So these groups here more or less do their activities independently of what we're doing, but our common coordinated activities are coordinated through this mechanism here. So we have our National Steering Committee that's going to meet tomorrow after they've had the opportunity to absorb the information that's presented here. And we have a management committee which consists of the node leaders, which meets quarterly to talk about what we should be doing, how we should be progressing. And then we have a number of technical program areas with different participants, 6 groups participating in total in the Australian operation, and involved in different activities to different extents, which I'll talk a little bit more about. So we have those 3 committees, annual meetings of the International Advisory Committee, generally in the US in connection with the IEEE Photovoltaics Conference. Would be in a convenient location for that. And then the National Committee meets biannually in connection with this conference and just before the International Committee meeting. And we have those 2 meetings. And then the Management Committee meets quarterly. And these are our technical program areas. So we span the whole cross-section of devices, I guess. So we do very little work in the systems or systems hardware area. So concentrated on improving the costs of photovoltaic devices and modules. So the silicon cells is an area where UNSW and ANU have traditionally been strong, so they're the key proponents in that area there. The next area is thin film cells, and there's a wider range of interest in that area. So most of the nodes are involved with that, and ANU will be involved in that in future as well, as we'll see. So becoming an area that all groups are participating in. So this sort of looking at next generation technology that may be able to displace the silicon cells. But the big news there that's going to have some impact upon our program has been the rapid emergence of perovskite semiconductors. So I think most people here would be aware of this particular perovskite, methyl ammonium lead iodide, has sort of very rapidly emerged from nowhere over the last 2 years. And this is just an efficiency chart. So a couple of years ago, groups were struggling with devices that, capable of 10% sort of efficiency, which many technologies can get to, but all of a sudden emerged from that and are now neck and neck with the best thin film photovoltaic materials that have ever been produced. So CIGS and cadmium telluride have shown some recent improvements, but not at the same rate as the perovskites. So, but when we prepared the original application for ACAP, perovskites were only known to, half a dozen people worldwide. So this has all happened since, since this very rapid emergence. So what we're planning to do is to adjust the ACAP activities to incorporate more perovskite work into our activities. And with the wide range of participants and the wide skill base that we've got to bring to bear on the perovskites, we're hoping to have a very serious look at their capabilities during the life of ACAP. So that'll be one change that we'll be making to our original program. So we already had strong programs in the organic and dye-sensitized and earth-abundant CZTS areas. So they'll continue, but perhaps de-emphasised to allow more perovskite work to be incorporated. And then we have optics and characterization, important area. So manufacturing issues, we're looking at the costing of the different options. So that's to provide a benchmark about how we're going and how the different technologies compare and so on. And then education, training and outreach is our final strand that all partners are involved with. Important thing, as far as we're concerned, the original idea that we get funded for 4 years and then get reviewed somewhere over that 4-year period with a possibility of extension to 8 years if all is going well. So in our original contract, the review was actually scheduled for next year, so no later than September of next year. We have to prepare a lot of documentation for that, so that coordinating all the information that's coming in from the 6 nodes is quite a major task. It might sound easy, but it's something that takes months to coordinate. So we thought it'd be better to have the review scheduled in relation consistently with the annual reporting requirements of the centre. So rather than having a separate period of information gathering, sort of bring the review to a period that would better coordinate with our normal information gathering activities. So after some discussion with ARENA, it seems like what we might be doing is moving the review to 2016, which is after 3 years of activity, so into our 4th year of activity, but scheduling it early in that year so we can take advantage of our information gathering activities and preparing our annual report and milestone reports. So that's the way things are heading at the moment. I just emphasise that a lot of our criteria for the review are based on collaboration between the centres, so that's been building up very strongly, and the perovskites is strengthening that even more so. So I think we're going to look very good on those fronts. Okay, well that finishes what I had to say, so I'll just give a brief overview of what we're going to do for the rest of the morning. So next we're going to have an invited keynote presentation from Mr. Hugo Lawrence, the US Consul General for Sydney. Given the US connections of the ACAP and the AUSIAPV overarching organisation, and that'll be followed by a keynote from Ms. Veronica Hurd from ARENA. So we'll hear about ARENA's thinking on that's relevant to our activities. And then we'll switch into a mode where we'll get presentation from each of the 6 node leaders. So that'll extend on into the afternoon, where we'll hear about what the different nodes have been doing and what their plans are for the following year. So we'll get progress and plans reports from those. And then tomorrow we switch into more of a research sort of conference mode where we get presentations from what the node leaders have indicated have been some of the key research results that have come out of their nodes over the past year. So later on this afternoon we'll also be having presentations from our US guests as well. So that's another thing that to look forward to. So without any further ado, I might invite Mr. Hugo Lawrence. Would you like to do the introduction, Richard? I've sort of done it, so we'll just move on. So Mr. Hugo Lawrence is the US Consul General for Sydney, and I invite you to take the stage.